Hi friends, today we are going to learn Quanta motherboard power sequence. In this screen you can see there are components this one is called the CPU processor, then this is a PCH, and the next one is SIO. Now today we'll learn Quanta motherboard power sequence. First we'll see how to identify the Quanta motherboard. Okay. So see in this screen you can see there are 4 types of motherboard. The Compil, Quanta, Inventec and Westron. So the Quanta motherboard number start from like a DA0, R13 or R33, R53 like that. And Compil motherboard number start from LA, and Westron motherboard number start from like a 5 digit and -1 or -2 or -3 like that. So any laptops require all these types of power. Suppose CPU require a 4 level of power, CPU require a 1.35 voltage if the DDR3L RAM, then 1.05 volt, then graphics core and CPU core. Then if the RAM is DDR3L, then RAM require a 1.35 volt, 3.3 volt, 0.75 volt. PCH require a 1.05 volt, 1.5 volt, 1.35 volt and 3.3 volt. BIOS require a 3.3 and SIs require a 3.3, and these are the different pulse width modulator. In there are I already told you there are different manufacturers of the motherboard like Compil, Quanta, Westron, Inventec, and they have a different power sequence. Okay, these are the basic concept of the pulse width modulator, and they follow the different sequence to flow the power. So here in the screen you can see the power sequence of the Quanta motherboard. I mention here from number 1, 2, 3, so it's very easy to understand. And these are my different pulse width modulator. Like this here is called always voltage, which generate a 3.3 and 5 volt. Always voltage means this voltage generate before power on. Means if you give a power, like if there is an adapter or whether it is a battery, this supply will be generated. So that is why it's called always voltage. This voltage is called the suspend voltage. This voltage is called the suspend voltage because this voltage is already generated, but when you press the power button, this voltage flow on the motherboard, and this rest of the voltage are the system voltage from here to here, like a 1.5 volt, 1.05 volt, 1.8 volt. The 1.5 volt goes to the CPU, RAM and PCH. If it is a DDR3 RAM, then 1.5, and the next voltage is called a system voltage, that is a 1.05 volt, and 1.8 volt that is goes to the CPU as well as to the PCH. This voltage is called the CPU core voltage, which generate something around 30 to 40 ampere current for the CPU core. The voltage level is something 0.9 volt, and the next voltage, that is a graphics core voltage, that is also same, something 9 volt. So these are the different pulse width modulators controlled by this chip. That is, this chip is called the Super IO, SIO. It's called the EC embedded controller also, or it's called the KBC, keyboard controller. Now we'll see how this power sequence take place. So these are my 2 inputs. One is adapter, the second one is a battery, and this is my the voltage section where laptop receive this 2 power. When the laptop receive this 2 power, he send out 1 power out. This voltage is called the voltage section, V in voltage, or it's called the B++ voltage. That's supposed to, if the adapter and battery both are connected, then I will get here adapter voltage only, and if the adapter is voltage absent, I will get here a battery voltage. That is, a battery voltage supposed to be 10.8 volt or 11.1 volt like that. So this 18 voltage goes to the different pulse width modulator. It goes to the always voltage, goes to the 1.5, it goes to the 1.05, 1.8 and CPU core, all the input section. In the pulse width modulator, I already explained you in the other video that how the pulse width modulator work. You can see that video also to understand the pulse width modulator. Now When the 18 volt is received to the different section, this pulse width modulator, only this section will respond. That is called the always voltage will respond, and he will generate a 3 volt, that is called the linear voltage. 3 volt linear voltage will come out, and this 3 linear voltage goes to the SIO. SIO is the entire manager of the laptop. So he receive the power, it's called always voltage, or it's called a VCC voltage. In desktop motherboard it's called a VSB voltage, 3 VSB. Okay, so SIO receive this power, 3 volt is received, and then the SIO wait to press the power on button. My next step is the power button. The power button, I'll get a 3 volt, and this the switch, one end is a 3 volt, another end is connected to the ground. So as soon as I press power button and I release that power button, here is a 303 volt pulse is generated, and it goes to the SIO. This pin is called the power button, NBS on and power on, like that. So you can see in the schematic also. I'll show you in the schematic also. So 303 pulse will be generated at this point. Once he receives this pulse, SIO omit one signal, that is called SLP S5 signal at the step number 4. He omit one signal, he send out a 3 volt. This signal is called the slip mode S5, and he turn on always voltage. In always voltage there are 4 section, 2 linear regulator and 2 pulse width modulator. One linear regulator, that is a 3 volt, that is called the VL voltage. This voltage goes to the SIO, and this 5 volt comes out, that is called a 5 volt VCC, that goes to the subordinate component of the always voltage. Once SIO send out this SLP S5 signal to the always section, he start up 2 pulse width modulator, and this 2 pulse width modulator started, and they generate a 5 volt and 3.3 volt, and this voltage will be halt here, and this 3 volt goes to the PCH also. That is my step number 4. Once always voltage generate this 3.3 and 5 voltage, this 3.3 and 5 voltage will be generated, and this 3.3 voltage goes to the PCH, and this voltage will halt here. The next thing is, once the PCH got the power, SIO generate a next signal, that is called the RSM RST. It's called the resume and reset. See, there are few reset signal. First of all, it's called the EC reset. The EC reset require to the SIO to work, that is generated once SIO receive the power. The next is PCH require a reset signal. That reset signal is called the resume and reset. So in Quanta motherboard, if your motherboard is not powering on, suppose if you press a power button and your laptop is not powering on, then you can straight away check this RSM RST signal. The RSM RST signal should be 3 volt. It should come out the 3 volt, and if this 3 volt is not coming out, that means your problem, probably your SIO, or problem your maybe the EC bias, or SIO not getting the power, or SIO not generate the EC reset. These are the few problems you can see. So once you press the power button, the next signal you have to check the RSM RST. Once the RSM RST comes within a few microseconds, SIO generate the next signal, that is called the post power button, that is called a PM power button, or it's called the DNB power button. That 303 volt pulse generated at this point, and this 303 pulse goes to the PCH. So once the PCH receive this signal, and he will understand ki SIO now asking to turn on the laptop. So once he receive this pulse, now the PCH will give the confirmation signal to the SIO. That signal is known as SLP S3 and SLP S4. These 2 signals sent by the PCH to the SIO. These are the 2 slip mode, SLP-S3 and SLP-S4. SLP-S4 is basically purpose for the turn on the system voltage, and SLP-S3 is used basically turn on the VRM voltage. Okay. So the next thing is they have an alternate name also. In some time you don't find this SLP-S3 and SLP-S4 signal, but in that case you will find the another name. It's called the SUSB and SUSC. These are the alternate name for the SLP-S3 and SLP-S4. So once SIO received this two signal, it's come from 0 to 3 volt from PCH. Now SIO now turn to the SIO. Now he will turn on the supply one by one. So it's first turn on sys on signal. He trigger this two MOSFET. My 3 volt and 5 volt is generated at this junction. This MOSFET has not passed to the entire motherboard. But once SIO omit this signal, as sys on signal he generate at 9 step, this 3.3 volt pass to from drain to source, and this 5 volt pass from this drain to source. So this voltage is called the suspend voltage, and this voltage spread entire motherboard. So the next signal is called SIO omit another signal, that is called sys on signal. Once SIO omit this sys on signal from 0 to 3 volt, my 1.5 volt will be turned on. My 1.5 pulse width modulator will turn on, and he will generate a 1.5 voltage, and this 1.5 volt goes to the RAM, PCH and CPU. So the next is SIO omit the 11 step signal, that is called a main on signal, and that main on signal he trigger this two pulse width modulator, that is called a 1.05 volt and 1.8 volt. He turn on this enable, gives the enable signal to this two pulse width modulator, and this pulse width modulator generate the signal that is called a 1.05 volt and 1.8 volt at step number 12. Now you can see in this different pulse width modulator generating a different voltages, and their power good signal reach to this point. All the pulse width modulator generate a power, and their power good signal collected at this point. It comes at this point. So once suspend on signal will generate, it send the power good signal. Always voltage power good signal goes there. 1.5 volt power good signal goes there. System voltage power goes there. It like that. So once all the powers are fine, all the powers are working okay, and that point here 3 volt will be generated, and this 3 volt signal is called HWPG at step number 13. If one of the voltage is absent from this line, your voltage will be 0 volt, and if the all voltage coming proper at this point, here will be 3 volt will be generated, and this signal is called HWPG. That's step number 13. After that, once SIO received this SWPG, he turn on a VR on signal. Otherwise he won't turn on the VR on signal. The VR on signal will be start lastly once all this power comes out. So before turning on the CPU core voltage, SIO check all voltage should be on proper line. The next is he turn on the core voltage, and this two CPU core voltage will be generated. One is called the graphics core to the graphics section of the CPU, and the next is called the VCC core to the CPU, step number 15. And once CPU received this power, he send out the serial signal, that is called a SVID, voltage identification signal, saying the what level of power or what level of current is required from the VRM section. And he communicate with the VRM section. This is called the SVID signal to the VRM section. After step 15.1, the VRM section omit one signal, that is called a IMVP power good or V gate or the VRM power good. These are the different name could be found on the schematic diagram. It's called maybe IMVP power good, or sometimes called a VRM power good, or sometimes called the V gate. All three names are the same things. Once the VRM section stabilize and this section omit one signal, that is called IMVP power good, saying that entire VRM sections working fine is sent to the SIO. Once SIO received this signal, now your all powers are okay, all power systems are working fine. So SIO omit one signal, that next signal is called the EC power okay or system power okay to the PCH, because PCH asked SIO to turn on all the power, and now he given the confirmation to the PCH saying that ki I done my job, my all power streams are working fine. Previously it was here 0 volt, now it's become a 3 volt, and once this 3 volt, this signal is called the system power okay. Once the PCH received this signal, system power okay, then he turn on this 3 signal one by one. The first he omit one signal, that is called the DRAM power good, that means the RAM power good. That's step number 18. Once PCH send out the signal, CPU send out another signal, that is called the DRAM reset. This signal you can check on the DDR3 RAM pin number 30. Here you should get a 1 volt. If you find a 1 volt here at pin number 30, that means PCH send the DRAM power good signal to the CPU, and CPU omit this DRAM reset signal to the RAM. Now is ready to communicate with the RAM. The next signal PCH send, that is called a CPU power good, and PCH saying to the CPU whatever the power you got, all the 4 level of power, that is called VTT, VCCP, CPU core and graphics core, all the power levels are fine, so you ready to work, that is 1 volt. And finally PCH omit one signal, that is called a PLT reset, that is called a platform reset. At this point he reset the entire motherboard. It's a 3 volt comes out, and this 3 volt you can check on the Wi-Fi card pin number 22, or you can check this PLT reset at SIO, mention over there as a PLT reset, and this voltage goes to the CPU, reducing the voltage, because the CPU require only 1 volt. So PLT reset send out the 3 volt, so there they put a resistor, a current voltage dropping resistor, and the CPU reset finally a CPU reset signal. And once CPU got the signal, CPU get resetted and ready to work, and after a next clock CPU access the DMI bus, access the PCH, and access this BIOS. This BIOS is called the PCH BIOS, and you can check at the pin number 1. Pin number 1 is my chip select, pin number 2 is a read. If you connect the oscilloscope here at pin number 1 and turn on the laptop, you will find some pulses like this, you will find some oscillation, and if this oscillation coming on the pin number 1, that means the CPU is ready, and CPU got the reset and is accessing the BIOS. And pin number 2, he read all the data and pass to the processor. In this way we can see how the Quanta motherboard power sequence work. Thank you very much.